In this tutorial, we will see how to perform the center of gravity method of location planning. The center of gravity method is an approach to determining the location of a facility that will minimize the shipping costs between various locations. Generally, it is used to locate one factory to serve multiple warehouses or one warehouse to serve multiple locations. However, it can also be used to locate service facilities such as firehouses or police stations. Basically, the center of gravity method finds the average location. Only it is a weighted average. In locating a warehouse, for example, each location will be weighted by the quantity shipped to each customer. We will see how to work these problems by way of an example. The chart on the slide shows 4 retail establishments. The table on the slide gives their X and Y coordinates along with their associated volume. We wish to find the location for a centralized warehouse to serve them. While this example uses a simple coordinate system, in today's world you would most likely use the GPS coordinates for each location. Any coordinate system can be used as long as it is used consistently. The formulas are shown on the slide. Basically, we are finding the weighted average of the X and Y coordinates. For the average X coordinate, 0.4 times 200 plus 0.8 times 150 plus 2.0 times 400 plus 4.0 times 500, quantity divided by 200 plus 150 plus 400 plus 500, all equals 2.40. This will be the X coordinate for the warehouse. See how easy that is? For the average Y coordinate, 0.8 times 200 plus 1.3 times 150 plus 5.0 times 400 plus 3.0 times 500, quantity divided by 200 plus 150 plus 400 plus 500, all equals 2.68. That will be the Y coordinate for the warehouse. That's all there is to it. The slide shows the original chart updated with the proposed location of the warehouse. Notice how the higher volume of D2 and D4 pull the warehouse closer even though D1 and D2 are located together. So, do we actually locate here? Not likely. A warehouse needs interstate access, lots of land, and the right type of zoning. The calculated location is just the general area in which we should start looking for a space to locate the warehouse. The chart on the slide shows 4 retail establishments. The table on the slide gives their X and Y coordinates along with their associated volume. We wish to find the location for a centralized warehouse to serve them. This time, notice that D1, D2, and D3 are all clustered together, but D4 has a much larger volume. Pay attention to how this impacts the location for the warehouse.
Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made.
For the average X coordinate, 1.0 times 100 plus 2.0 times 75 plus 3.0 times 125 plus 1.0 times 600, quantity divided by 100 plus 75 plus 125 plus 60, all equals 1.36. This will be the X coordinate for the warehouse. For the average Y coordinate, 5.0 times 100 plus 5.5 times 75 plus 4.0 times 125 plus 1.0 times 600, quantity divided by 100 plus 75 plus 125 plus 600, all equals 2.24. This will be the Y coordinate for the warehouse. The slide shows the original chart updated with the proposed location of the warehouse. Notice how the higher volume of D4 pull the warehouse closer, even though D1, D2, and D3 are located fairly close together. If this video helped you working operations management problems, please consider liking the video and subscribing to the channel.